right, example number 2. Part I says, determine the non-permissible values. Well, non-permissible values are things that are not allowed, things that make the function undefined. What are we not allowed to do? Divide by 0, take the square root of a negative. So we have to see in this question, is there any places where we would divide by 0? Well, in part A, we have cotangent theta and cosecant theta. And a good way to see if you're going to divide by 0 is to change things to sine and cos. So if I change cotangent, that's cos divided by sine. And if I change cosecant, that's 1 divided by sine. On the other side, I have cos theta. So I'll just leave the other side as cos theta. Am I dividing anywhere? Yes. I'm dividing by sine theta here and here. I'm also dividing by this whole thing. Can you see that whole thing is on the bottom of a fraction? So first we're going to deal with sine theta. Is sine theta ever 0? No. Yes, it is. Okay. When? So if our non-permissible values are NPVs, theta can't equal what? When is sine theta equal to 0? Sine theta is equal to 0 at 0, pi, 2 pi. Is that it? And forever. 0 pi, 2 pi, and forever. How do we write that? K pi. Can equal k pi where k is an integer. Good. Now look at that red box. Because if that fraction, 1 over sine theta, is ever equal to 0, we'll have more. But it begs the question, when is a fraction equal to 0? Can you give me an example of a fraction that's equal to 0? With actual numbers, not with sign, not with anything like. Give me an example of a fraction that's equal to 0. 0 over 2. Everybody agree that that's equal to 0? Yes. Good. Can you give me another fraction that's equal to 0? 0 over 3. Awesome. Hopefully we'll see a pattern here. 0 over k. Ooh. 0 over anything you're saying is equal to 0? What's the overall pattern here? For a fraction to equal 0, 0 has to be on the top. Will that red box ever equal 0? No. See what we just did? Right? At first, if I would have just said to you, when is the red box equal to 0? You would have been like, oh. And you would have thought, and you would have thought, and then you eventually probably would have said, I don't know. Right? Do you think that might have happened? Okay. But if we look at an idea, when is a fraction equal to 0? And this is a big idea. It comes up a lot in a lot of different math classes. When is a fraction equal to 0? It's only when the numerator is equal to 0. So when we're asking when is 1 over sine theta equal to 0, we're really asking when is 1 equal to 0? Never. So in this case, these are the only non-permissible values. Okay? Now, to prove this identity, part B says prove, or part II says prove this identity. Again, we draw our line here. What can we change? We can change the two values on the left. And this is a great example of where changing things to cos and sine is going to be helpful. Okay? First of all, the right-hand side is cos already. So when we choose cotangent, you have a choice to change it to cos over sine or 1 over tan. In this case, it makes more sense to change it to cos over sine. We don't have tan on the right. Adding tan on the left isn't going to help us. We'll probably have to change it to sine or cos eventually anyways. So changing to cos over sine, draw a bigger line here because cosecant is 1 over sine. And now we have a fraction divided by a fraction. Multiply by the reciprocal. Notice that the sine thetas are the exact same factors. And you're just left with cos theta. So therefore, left side equals right side. And we're done. Part B. Okay, can we change it? I'm going to change that secant theta to 1 over cos theta. Notice that you're dividing by a cos theta there. We're going to have to check that. And in our big fraction, we're dividing right here. Can you see the places where we're dividing? So to begin with, theta can't equal. When is cos theta equal to 0? Pi over 2, 3 pi over 2, 5 pi over 2. How did we write those ones? Could start with one of them, pi over 2. And the distance between pi over 2 and 3 pi over 2 is pi. And the distance between 3 pi over 2 and 5 pi over 2 is another pi. So if you start with pi over 2 and add k pi, where k is an integer, you'll hit them all. Do you remember the other way that we wrote them? The other way that we wrote them was all odd pi over 2, although you can't really write odd pi over 2, where odd is part of the odds. Yeah, it doesn't really work. The way that we wrote this was start with an even number, 2 times k. Add 1 to that to make it odd. So 2k plus 1 pi over 2, where k is an integer, is the other way you could write this. Whichever of the two is easier for you to remember because it makes more sense to you. If you like the pi over 2 plus k pi, because you can imagine going by pi's, starting with one that you know. Or if you like 2k plus 1, because that makes sense that that's an odd number, times by pi over 2. Either way. What about here, the red box? Is it ever equal to 0? Okay. Well, is it a single fraction? No, it's not a single. You could write it as a single fraction. Okay. I'm going to rewrite the red box. Inside of this red box, I'm going to make the 1 cos over cos, so we have a common denominator. Then I have a single fraction. Is that ever equal to 0? What has to happen for a fraction to equal 0? The top has to be equal to 0. Is it possible for cos theta plus 1 to equal 0? In other words, is it possible that cos theta equals negative 1? Does that ever happen on your pi plate? Yes. When? At pi. When else? At 3 pi. When else? 5 pi. So it also can't equal pi plus 2k pi, where k is an integer. Nice. So, part 2. Let's prove this one. What can we change? Secant theta. So we're going to have 1 plus cos theta over 1 plus 1 over cos theta. Make them both single fractions. 1 plus cos theta is already a single fraction because you can make it over 1. And on the bottom, if you have a common denominator of cos theta, you'll get cos theta plus 1 all over cos theta. Fraction divided by a fraction. Multiply by the reciprocal. Can you see that these get grouped together? And these get grouped together. Do we have any factors that are identical? Yes. This is a good question because I want you to look at this right now and this right now. Because people get stuck not recognizing that 1 plus cos theta is the same as 1 plus cos theta over 1. And that you do have a single fraction on the top. If you recognize that, then you can, oh yeah, I have a fraction over a fraction, I can multiply by the reciprocal. Sometimes people get stuck at this point without seeing that, and then that holds them back. So we need to end by saying the left side equals the right side. Nice. Okay, for this one, questions 4, 8, 9, and 11.